This is GATE 2016 set 2 electrical question number 38. The single line diagram of a balanced power system is shown in the figure. The voltage magnitude at the generator internal bus is constant and 1 per unit. The per unit reactances of different components in the system are shown in the figure. The infinite bus voltage given as 1 per unit. A three-phase fault occurs at the middle of line 2. The ratio of maximum real power that can be transferred during pre-fault and fault state condition is being asked. For NPTEL reference, you can refer to lecture 55 Star Delta and Delta Star Transformation of the NPTEL course Network Analysis by Professor T.K. Bhattacharya, Department of Electrical Engineering, IIT Kharagpur. For useful data, you need to know that between two buses of voltage magnitudes V1 angle delta 1 and V2 angle delta 2 with the line reactance being X, that is the magnitude is X, the power, that is the active power transferred from bus 1 to 2, let us say, is given as V1 mod into V2 mod divided by mod of X, that is magnitude of reactance, that is reactance, line reactance magnitude into sine of angle difference between the two bus voltage angles. So maximum value of this power transfer is being given as V1 V2 by X. Delta to star transformation, if the delta impedances are ZAB, ZBC and ZAC, then find out the star impedance of phase A. It is given as ZA equal to, now if it is ZA, then we need to find the two impedances attached to A of the delta, that is ZAB into ZAC divided by sum of the impedances of delta. Now for star to delta, if you want to find out the delta impedance between nodes A and B, that is ZAB, then you need to assign, if this is AB, this should be ZC in the denominator and divided by sum of two term product of the star impedances. Now coming to the solution, given is like this is J.2 and this is the bus, and this is J.1 and this is J.5, and this is given as J.1 and J.5, and this is the infinite bus of the system. Then this bus and this bus are in parallel, so we can write like this: J.2 and this is J.6 and parallel, so by 2.3, and this is the bus like this. So this is nothing but J.5. So in this case, that is pre-fault condition. If this is 1, this is 2, P12 max, and the magnitude is given as 1 into 1, because the voltage magnitudes of both the buses are 1 per unit, this is in per unit, divided by J.5. So 0.5 is the magnitude, this is 2 per unit. Now during fault at middle of line 2, that is this line, so there is a fault. Now it is given that fault occurs at middle of line 2, so now this is J.2, this is J.6, this is infinite bus, and this line initially it has the J.1 impedance, and then you have the lumped parameter impedance J.5. This is lumped. Now split it into two, J.25, J.25, which models this half portion of the line, and this models half portion of the line 2. So middle of the line, because this is the transformer impedance, so after that the line is existing, and when the fault occurs at the middle of the line, half of the impedance of the line lies in this part, half of the impedance lies in this part. The equivalent model will look something like this with the impedance specified: J.2, J.6, J.35, and this is J.25, where this is the infinite bus, this is the fault. Now this is one node, this is another node, this is another node, 3 nodes. We need to convert this delta connection into the star connection for simplification of the circuit. So now let's convert this from delta to star. So this node, and this node, so it will come something like this, where this node is A, this node is B, so this node is A, this node is B. So this is ZA, this is ZB, this is ZC, this is C, this node is C. So ZA in star is, as per the formula, ZAB ZAC divided by ZAB plus ZBC plus ZCA. Now ZAB, which is 0.6 in delta, now ZAC is 0.35 divided by 0.6 plus 0.35 plus 0.25. So this is coming out as J, because this is all J and this is J, this is J, 1 J cancel. Now ZA is coming out for the star converted impedance. So it is coming out as 0.6 into 0.35 divided by 0.6 plus 0.35 plus 0.25, 0.175. So this is 1, and then you will find similarly ZB to be 0.125 and ZC to be 0.073. Now from here we know that the impedance, when this will be converted into its equivalent delta, so star to delta now is J.2 and this is B. So between A and B one impedance will come and other impedances will go to C. So this impedance we need. So this is ZAB. Now ZAB equal to, we want to find delta from star. So the formula is, if this is ZAB, then this should be ZC and the dual product in star. So ZA ZB plus ZB ZC plus ZC ZA. So ZAB equal to 0.175 into 0.073 plus 0.175 into 0.125 plus 0.125 into 0.073 divided by ZC, which is 0.073. So it is coming out as J 1.143. So P max at faulted condition in per unit between AB is 1 into 1 divided by 1.143. So this is during faulted condition. So pre-fault P max pre-fault divided by P max fault equal to 2 divided by 1 by 1.143 equal to 2 into 1.143 equal to 2.286. This is the answer. So the ratio is 2.286. This is the answer. Thank you.